Okay, so we're nearing the end of our quantitative data part of this unit. It feels like we've been in this part forever, but I don't want you to forget that we've also gone over categorical data, and now we've been spending quite a bit of time in quantitative data. And the last two things that we have to talk about are box plots and comparing distributions. So what we're going to talk about today is comparing distributions. I brought you a note sheet. We'll get to this note sheet next. But to set us up for comparing distributions, I want to look at this back-to-back stem plot that I had you guys wait on when we first learned stem plots and histograms and dot plots. So the reason that you make a back-to-back stem plot is to compare distributions. So I'm going to write up here for comparing distributions. We look at back-to-back stem plots so that we can compare distributions. We're going to use your data, your shoe data, to make a back-to-back stem plot. So I'm going to do, I think I'll do stems 0 to 5. Leave a little bit of space here. So leave a little bit of space, and then you can do 0, 1, 2, 3, 4, 5. And you want it to be in the center of your paper, not to the left of your paper. When you do a back-to-back stem plot, you not only have a vertical line to the right, but now you're also going to have a vertical line to the left. And then we're going to split your data set for shoes into boys and girls. So on the left-hand side, I'm going to record how many shoes the boys had. And on the right-hand side, I'm going to record how many shoes the girls had. So let me separate yours out really quick. Okay, for the girls, the first one is 21. So we're going to put a 1 next to the 2 for 21. Then 12. 40. Dang, Gina. 28. 3. Oh, just kidding. Don't write that one down. That was a boy. Oh, this one was 3. So 3. So we've got 5 girls so far. So 3, 12, 21, 28, and 40. Okay, 15. 10. 10. 3. 11. 12. So that's for the girls. Then for our boys, we have 3, 5, 12, 4. So at this point, our data set is very small because there are not very many of you in this class. But even with this small of a data set, I can already see that there's a difference between the number of shoes that girls own versus the number of shoes that boys own. The boys have a peak between 0 to 9, and the girls have a peak from 1 to 19. So just so that we can get a better picture, I'm now going to add on the data from the other two stats classes that I have. So these are from 1A and 2B. So let's start on the girls' side again. So 3, 9, 9, 5, 8. Okay, this one's a long one. 10, 16, 15, 15, 15, 13, 15, 10, 13, 5. Just kidding, 15. Sorry about that. Okay, now we're in the 20s. 20, 20, 26, 28, 23. And then the last one is 30. Wow. This is the first time that I've done this, and the distribution is almost roughly symmetric. Like without these two right here, without the 30 and the 40, that distribution I think would be symmetric. That's the only time I've ever seen that in all the times I've done this. How interesting. Okay, let's go on the boys' side now. 2, 9, 3, 3, 5, 3, 2, 2, 8, 5, 3, 9, 6. Next stem, we have 13, 10, 10. We have one that had 21, and we had one that had 58. Okay, so if we want to look at the girls' distribution, we turn it to the side and look at the horizontal, look at it from left to right. So like I was saying, I think that the girls is roughly symmetric. I think that these two are possible outliers. If they're not outliers, they're definitely causing a little bit of skew on this distribution. Would you guys agree? I don't think that their data is very spread out because most of the girls own between 3 and 28 pairs of shoes. So I don't think that spread is too big. To look at the boys, I know that this probably seems weird, but you want to look at it like from the back of the page up against the light, so that your 0 stem is on the left-hand side and your 5 stem is on the right-hand side. So this, the boys' distribution is right skewed. The boys' distribution would be right skewed even without this boy that had 58, and I already know he's definitely an outlier. I don't even need to calculate 1.5 times IQR to know that whatever boy had 58 is for sure, if we went through and calculated it, mathematically an outlier. We can tell, or at least I'm hoping that we can tell, that just by looking at these two, that girls tend to own more shoes than boys do. Can you guys see that? and that most of the boys are in the 0 stem, so 0 to 9, and most of the girls are in the 1 stem, so 1 to 19. So part of what I want you to do as homework is I want you to formalize this stem and leaf plot. And what I mean by that is I want you to add a key, and then I want you to split the stems. So you'll have 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Because I think that that's going to give us a much better idea about what these shapes really are. Then when you go through and redo this, make sure that your leaves are in order. So for the lower stem on the girls, it would be 3, 3, 3. And on the upper stem, it would be 5, 8, 9, 9. And notice that my numbers line up vertically. So this is where you go through and you order out your leaves. On the boys, you start from least to greatest. So your first leaf would be 2. Actually, you have 1, 2, 3 2s. So it would be 2, 2, 2. And then you have 1, 2, 3, 4, 5 3s. It's really hard to keep those straight. Holy moly. Do you guys understand what's happening here on your split stem? Yes? So that is the preview for what we're about to formalize on our comparing distributions worksheet that I brought you. So finish up whatever stem you're on and then go to that note sheet. So this is the note sheet that I want you to go to. So when I say formalize, what I mean is now I'm going to give you specific examples of what they want you to write when you compare two distributions. Because we just did that, or I did it with you on this data set. I said, well, it looks like the girls typically own more shoes than the boys. This guy is definitely an outlier for the boys. There's maybe outliers for the girls. The spread, if you don't consider the outliers on both, is not very big. And this guy almost looks symmetric, but this guy is definitely right skewed. So now we formalize that. If they ask me to write a response, I'm now going to show you what they would expect you to write. So we're on a new data set. This says some of the most interesting statistics questions involve comparing two or more groups. And in the case we just looked at, we were comparing the boys' shoe data to the girls' shoe data. Which of two, so these are questions that you might want to investigate. Which of two popular diets leads to greater long-term weight loss? Who texts more, males or females? Does the number of people living in a household differ among countries? These are all questions that some people might be interested in. And that last question is what our example is going to investigate. So, to the right are dot plots of household size for random samples of 50 students from the United Kingdom and South Africa. So I'm just going to quickly highlight that this is 50 students in both, because I need to know N if I'm going to find the center. compare the distributions of household size for these two countries. So let's just start on the top one, the bluish purple one that is South Africa. And let's just make sure that we know what these dots are telling us. So for instance, this dot right here is telling me one student had 15 people that lived in their house. This bar here, or this set, tells me 4 students have 3 people living in their house. Is that making sense what's happening here? Was that a yes? Okay. So let's look at shape. Shape for South Africa. What are you guys thinking the shape of this distribution is? Right skewed. He is right skewed. And this guy, I'm almost sure that that is a legitimate outlier. And that's part of why the data is right skewed. Even without that outlier, I still would conclude that it's right skewed because this kind of looks like a set of stairs going down. Okay, the United Kingdom. What are you guys thinking on this one? I personally think he's roughly symmetric. I don't think you have much of a stair on either side. So I'm thinking that in the UK, the shape of the distribution is roughly symmetric. Most of the students had a household with 4 people living in it. So that's probably like mom and dad and 2 kids. So that's the first thing that we compare then when they ask us to compare distributions. So moving over to the shape, it says the distribution of household size for the United Kingdom sample is roughly symmetric, because that's the red one on the bottom. Roughly symmetric and unimodal. So it has a peak at 4. While the distribution for the South Africa sample is right skewed, or you can say skewed right, whatever you prefer, and unimodal. So for the UK, they have a mode at 4, and for South Africa, they have a mode or a peak at 3. So that's how we handle shape. We just basically list out the UK is symmetric, South Africa is right skewed. You always have to add specific context in these problems because you're comparing 2 different distributions. You want to make it clear which one you think is skewed and which one you think is symmetric. You can't just say, well, one of them is right skewed and the other one is symmetric. You have to be specific. Okay, next up is center. And because South Africa is skewed right, what should we use for center? Median. And if we're going to look at the median for South Africa, then we should also use the median for the UK. So they told us, going back to the prompt, they told us that this was 50 students. So your median is going to be between the 25th and 26th observation. Are you guys okay with that? Okay, so we go through and we count dots. We count until we get to the number that has the 25th and the 26th observation on it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So I am on the 6 for the household size. The 25th and 26th observation are on that set of dots, is in that set of dots. So the median for this guy is 6 people in a household. So you guys take like 30 seconds, maybe more than that, and find the median for the UK. So you guys go through, find the median for the UK. Is 20 seconds enough? Yes. Ten. 5, 3, 2. So I got 4. Is that what you guys got? Okay. So center. Household sizes for the South African students tended to be larger than for the UK students. Notice I'm giving specifics. The typical, do we think that's the word typical? Nope. The medians, of the household sizes for the two groups are 6 and 4 respectively. Have you guys seen that phrasing before? That respectively? So what that means is, if you go back up in the problem, the first country that they mention is South Africa, and the second country that they mention is the UK. So when they say respectively, what they mean is this first number matches South Africa, and this second number matches the UK. Okay, so we got shape, we got center, so we know the different shapes. We know that typically South Africa has a larger household size than the United Kingdom. And now we're going to talk about spread. So for this spread, we are going to use the range because that's pretty accurate if we exclude this outlier, which we can't, but the easiest thing to do here to compare these spreads is to use the range. And this is from the textbook. So I've pulled this basically from the textbook. So the household sizes for the South African students, well, let's check. The lowest is 3. What was the highest? I think it's 26. And then what was the lowest for the UK? 5, 4, 3, 2. I think this scale is wacky, but I think that's 2. To what's the highest number? 6. So the household sizes for the South African students vary more from 3 to 26 than for the UK students, which was 2 to 6. So the data varies a lot more for South Africa than for the UK. South Africa has a range of 23, but the UK has a range of 4. That's a big difference. I think I'm gonna write that down. I'm gonna write range here is 23 and range here is only 4. And then the last thing that they want us to address is whether or not there are outliers. So we've already discussed, there definitely seems to be an outlier in South Africa. I mean, 20, where are all these people sleeping? Is this like a super mansion? What is happening here? But on the UK, does there appear to be any outliers? No. So the first one they ask about is the UK distribution. So I'm going to say there does not appear to be any outliers in the UK distribution. The South African distribution, and this is from the book, so they say seems to have 2 outliers. So the South African distribution seems to have 2 outliers in the right tail of the distribution. Students who reported living in households with 15 and 26 people would be the outliers. I'm not sure that 15 is an outlier, but I'm sure 26 is. So now if I zoom out, we can see that we have done SOCs to compare these. When it says compare, what they want you to use is SOCs. So we've gone through shape, center, spread, outliers. And the last thing on this page is telling you, when comparing 2 distributions of quantitative data, it is not enough to just list the values of the center and the spread. You have to explicitly compare them using words like greater than, less than, or about the same, or more, or less. So I'm going to highlight that. You have to explicitly compare, meaning you have to use words like greater than, less than, so forth. So we cannot just say the median for South Africa is 6 and the median for the UK is 4. Even though it's obvious 6 is bigger than 4, they want you to actually say the median for South Africa is larger than the median for the UK. And now if we revisit, we can see we did say larger and we did say varies more or vary more. One other thing that I would like to highlight is that in our back-to-back stem plot data, we were looking at or comparing the same exact data set. So this was all from AP Stats students. Y'all don't need to be cleaning up. Y'all don't need 5 minutes to wipe down your table. Lovey-doos. So this is from the same set of data. This is 2 different sets of data. This is 50 observations from South Africa and 50 observations from the UK. So you can compare distributions from the same data, or you can compare distributions from different data sets. So on this one, we have dot plots, but if you turn the page, once you compare histograms, things get a little bit different. You have to use a different method for looking at or comparing histograms if they have a different number of observations. So this is what you guys will finish on Friday. I will make a separate video for this. And then you guys will do the box plot page that I brought you that's just front and back. Your homework for today is, can you do number 5? So today's homework is number 5. Friday's work is comparing histograms and your box plots paper that I brought you. We okay there? Okay.